All right, we're continuing our discussion and testing of the claim that insecticide-treated bed nets actually do reduce malaria among infants. And we are about to draw the distribution. And as I draw it, two things you should understand. First of all, this is a normal distribution, and what it represents is all the possible differences between any sample proportion from the first population, that is infants that got to use the bed nets, minus any possible sample proportion that we could have gotten from the second population, which is the set of infants that did not get to use the bed nets. And we are assuming that there is no difference between those two populations. So if we're assuming there's no difference, then hopefully it makes sense to you that the difference that should come up the most often when we subtract the one proportion from the other is that it should be zero, most of them. So we're saying smack dab here in the middle is 0. And again, this represents differences between proportion 1 and proportion 2 from samples. And this is any possible sample we could have gotten from the first one in its proportion, and any possible sample we could have gotten from the second one in its proportion. It is going to be a normal distribution. Okay. Well, what we need to do now is take a look at the actual study that was done and look at the actual specific sample information. So here we go. Here are the study results. They took a sample of 343 infants that were using the bed nets, and they found still 15 out of those 343 infants did develop malaria. Okay. Well, for the second population, we have a sample of 294 infants, and out of those 294 infants that were not using bed nets, 27 of them developed malaria. Now, I want to know, are these results pretty much the same, or is there a significant difference? Okay. The next new thing, hopefully the last new thing we have for this particular type of problem, is we have, of course, a new test statistic. This is just, in other words, how we calculate the z-score. The test statistic z is going to be found by doing the following. We're going to calculate the difference between p hat sub 1 and p hat sub 2, and subtract from that the difference between the two populations, which we're assuming is to be 0. So really, we're going to be subtracting 0 every time, so we really don't even need that, because we're assuming that it's 0. Now, as you might recall from doing test statistics in the past, we always divide this by some square root, and here, let me fill out the rest of this then. The numerators for this square root is going to be p bar times q bar. Again, p bar is the pooled sample proportion, and we're going to be dividing it by n sub 1, plus p bar times q bar divided by n sub 2, the size of the second sample. So it's time that we actually made all these calculations so we can actually plug them into this formula. Notice that we need p hat sub 1. P hat sub 1 is the proportion of infants that got to sleep with bed nets that still developed malaria. So let's use our calculators here. So we turn it on, and we're going to take 15 divided by 343, and that turns out to be 0.04373. Let's take that many decimal places. 0.04373. So approximately around 4% of these infants still develop malaria. For the second sample, from the second population, that's 27 out of 294, and that's 0.0918, and we'll round that to a 4. So 0.09184. I think I've got 5 decimal places for each one. Okay. Well, for these two samples, the difference between them wasn't 0. When I subtract p hat sub 1 minus p hat sub 2, I'm going to get, let me do that, 0.04373 minus 0.09184. That gives me a difference of negative 0.04811. Okay? Now, here's the point. We're going to take this value of approximately 5%, right? 0.04811 is approximately 5%, and it's negative, and bring it up on here. So let's say it's approximately, I don't know, right here, 0.04811. The question is this value so far away from 0 that it has such a low probability of occurring that it really shouldn't have occurred? And yet, from our sample information, it did occur. And if it did, then that means something is wrong. And if something is wrong, probably what's wrong is our assumption that the middle actually is 0 when it shouldn't be. So what we need to find out is what is the probability that we would get this number that is this significantly far away from 0. We need to find out what its probability of occurring is. And we said we're going to test it at a significance level of 1%, which means to say that it is very far away from 0 means it has a probability of less than 1% chance of occurring. So let's finish our calculations. N sub 1, we know, is simply the size of the sample, which is 343. N sub 2 is 294. Here comes the big calculation. The p-bar is going to be equal to the total of all the, quote, successes, really not much success catching malaria, huh, divided by the total that's in the two samples. So let's do that. So that's going to be parenthesis 15 plus 27, and notice I have parentheses around this numerator, divided by, and I've also got parentheses around my denominator of 343. If you don't put those parentheses in there, your answer is going to be bizarre. Will not be correct. And I get, this is equal to approximately 0.06593. Okay, well, we also need to calculate Q-bar, and Q-bar is just this number's complement, so that must be 0.93407, just subtracting this from 1. Okay, here comes the big calculation, so let's fill in the numbers first. I want to calculate my test statistic Z, and what it is going to be p hat sub 1 minus p hat sub 2, which you've already calculated as being negative 0.04811. We're subtracting, well, this difference is always going to be 0 if we assume that there's no difference. In my square root, I'm going to have p-bar 0.06593 times q-bar 0.93407, and that's going to be the same numerator in my second fraction, so let me go ahead and write those numbers in, times 0.93407. We're going to divide it by n sub 1, which is 343, and divide it by n sub 2 in my second fraction, which is 294. And once again, we will finish this up in our third video.